Black holes are one of the most mind-bending and confusing topics in our universe. The thought of something so massive, so densely packed that nothing can escape its gravitational force, not even light, is just mind-boggling. Now, this may sound absolutely crazy and like some absolute insanity, like something from a sci-fi film, but it is completely possible that our own universe could be inside of a supermassive black hole.
Like that's ever gonna happen. What a load.
Somebody once told me the world is gonna roll me.
This is a theory I recently heard about, the black hole cosmology theory, and when I heard about it, I definitely fell into the black hole.
Oh, hell no, man. What the?
First, we must understand what a black hole is. A black hole is a region of space packed so densely with enormous amounts of mass that cause immense amounts of gravity, trapping everything that passes a certain line, including light. This line is called the event horizon, and it is this point where it is no return. Nothing can escape a black hole once it is past the event horizon. Not even light. Black holes are typically formed after a supermassive star can no longer release energy from fusion. Gravity then forces the outer layers to explode off of the core and eject into space, causing what we call a Type II supernova. Then, the remaining core, with a mass of over 40 solar masses, one solar mass is equivalent to the mass of our own star, the Sun. That is what we call a black hole. We can theoretically make anything into a black hole using this equation to find an object's Schwarzschild radius, which is how small you would have to compress an object, based on its mass, to form a black hole.
Sorry, I just think I'm too stupid to understand this.
For example, if we wanted to turn our own planet, the Earth, into a black hole, we would somehow have to compress it down to the size of a blueberry. We would then have a blueberry-sized black hole. Or blackberry. I don't know.
What is going on with you? What are you talking about?
The closest confirmed black hole to Earth is Cygnus X1, a double system. There is a black hole next to a blue supergiant star, slowly eating away everything that reaches its event horizon. In fact, we have found that there's a big black hole in almost every large galaxy we have seen. We cannot see black holes, as they eat away the light sucked into the event horizon, therefore we can't see the light reflecting off of them. But we can see something called Hawking radiation. This is caused from hot gas and radiation leaking from the outside in a thermal form. We were able to capture an image of this with the Event Horizon Telescope, one of the greatest things humans have ever achieved. Scientists used 8 different observatories in locations around the globe, including Chile, Spain, Hawaii, Mexico, Arizona, and the southern Arctic Pole. We were able to sync these telescopes together and point them in the same direction at the same time and essentially create an Earth-sized telescope. We combine these images together to get this one, and this is the only possible way we could have taken this amazing historical photo. You may be asking, how would we not get stretched and crushed by all this gravity? Well, it's true. In a small to medium-sized black hole, with a mass ranging from 3 to 10 solar masses, we would be what scientists like to call spaghettified. As you would pass the event horizon, you would start traveling the speed of light, and different parts of your body would be experiencing different strengths of gravity, stretching you into human ramen noodles. It would be a terrible, violent event, and almost instantly. However, in large, supermassive black holes like the one in the previously mentioned photo taken by the Event Horizon Telescope, we are talking about such a giant scale, millions, even billions of solar masses. Known as Messier 87 or M87, In the Virgo constellation, this giant monster is 5.4 billion solar masses. With these behemoths, after you pass the event horizon, because it's such a massive scale now, spaghettification would be lessened so much we probably wouldn't be affected much or at all, really. So, now that we know about black holes, let's discuss the observable universe. The entire universe is not the same as the observable universe. We don't know the true size of the entire universe. It could even be infinite. We really just do not know at this point in time. The observable universe, however, is just that, what we can observe or see, because the light has had the time to reach us, and we can see it therefore. We know that the universe is expanding over time, yet there is always a point at which we cannot see yet because the light has not reached us yet. This is where the Big Bang happened, 13.8 billion years ago.
Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started.
I was talking about the actual Big Bang, not,
I'm over here, Sheldon.
that.
It's the biggest piece of dog shit.
And we can see the remnants of the first visible light in the universe created by the Big Bang within the cosmic microwave background, or CMB. This, ideally, is the fossil remnants left over from the Big Bang. It is also the point at which we can no longer see light. So, is the cosmic microwave background the event horizon of a supermassive black hole that our universe is inside? Well, both events start with a super dense compressed amount of matter leading to a singularity, then leading into a massive infinite expansion. And also, if we take the estimated mass of the observable universe, 5 times 10 to the power of 53 kilograms, and put it into the black hole equation to find its Schwarzschild diameter, we find out that we would have to compress the observable universe into a sphere with a diameter a little bit bigger than the observable universe, with the observable universe having a diameter of 93 billion light years across, and the Schwarzschild diameter being an estimated 157 billion light years across. This makes sense, why we know the universe is expanding, time is flowing, but we cannot see past a certain point outside the observable universe no matter what, because the light needs to reach us. It needs to pass the event horizon and then travel to us. So, after going over all of this, we can break it down to this. A singularity equals a black hole. A singularity is what created the Big Bang. Is the Big Bang the creation of a black hole? Are black holes the creation of other universes, therefore supporting the multiverse theory? This would also mean that space and time are both bigger, more massive than we thought, possibly even more infinite.